So we're going to look at polynomial and synthetic division. In this episode, we're going to look at long division. Notice that we're taking a polynomial, we're dividing it by a smaller polynomial, and we'll use division, multiplication, and subtraction, just like the long division that we did with the numbers. Alrighty, so here we have x minus 1, and we're dividing it into x cubed plus x squared plus 4x minus 6. And so the first question that we need to ask is, how many times does x go into x cubed? That's right, we're just looking at the x from the x minus 1, and we're just looking at the first term of x cubed. So how many times does x go into x cubed? Okay, goes in x squared times. Okay, so what we do is we put the x squared on top over the other x squared, okay? And we multiply the x minus 1 by x squared. And when we do that, we get x cubed minus 2x squared. Then we have to change the sign. Remember how we do subtraction? Well, when we subtract these, we have to change the sign and we're going to add. So it's easier with polynomials to think about change the signs and add, okay? And so when we do that, notice that the x cubes cancel and we get 2x squared. So we're going to bring down the 4x. And then the next thing we have to ask ourselves is how many times does x go into 2x squared? It goes into 2x squared 2x times. Okay, and that's what we write on top. Then we're going to multiply x minus 1 by 2x. All right, and when we do that, we're going to wind up with 2x squared minus 2x. Again, we change our signs and we add them. Okay, and this cancels out the 2x squares, and then we get 6x. We're going to bring down the negative 6. So how many times does x go into 6x? That's right, it goes in 6 times. So we add the plus 6 to the top. Then we're going to multiply the x minus 1 by 6. This will give us 6x minus 6. We have to change the signs and then we add them. And in this case, notice that we don't have a remainder. Let's take a look at this long division problem. Okay? Again, we're going to ask ourselves, how many times does x go into x squared? Well, it only goes into x squared once, x. And then we'll multiply the x plus 3 by x to get x squared plus 3x. Then we change the signs and we add them together. And so we get 5x plus 15. So our question is, how many times does x go into 5x? That's right, it goes in 5 times. And then we multiply the 5 by the x plus 3, and we get 15 plus 5, 15, 5x plus 15 when we do that. So again, we're going to change our signs and we add them together. Okay, and this gives us another 0. You can check this by taking x plus 3, x plus 5, and go ahead and FOIL them out. And you'll notice that you get x squared plus 8x plus 15, which is what our division was. All right, here's another one. But notice that we have x cubed minus 27 divided by x minus 3. Okay, but we're missing a bunch of terms between x cubed and the 27. And this is very, very important because you have to put in placeholders. Okay, we're missing terms. Notice how we put in term holders. Okay, we put in a 0x squared and a 0x. Again, how many times does x go into x cubed? Well, it goes in x squared times, right? So we put the x squared down. Then we have to multiply the x squared by x minus 3. Notice that we'll get x cubed minus 3x squared. Again, we must change our signs and add, and thus we get 3x squared plus, again, 0x. And again, we have to ask ourselves, how many times does x go into 3x squared? It goes in 3x times. So again, we'll multiply the 3x by x minus 3, and this time we'll get 3x squared minus 9x. Change our signs, add. Now we have 9x, and we bring down the minus 27. How many times does x go into 9x? Well, it goes into 9x just 9 times, right? So then we take the 9, and we have to multiply it by x minus 3. So we get 9x minus 27, change our signs, add them, and again, we have a 0 remainder. Okay? We're going to, again, take a look at this. Again, x goes into x squared just 1x times. Then we have to take that x, go x minus 4 times the x minus 4, so we get x squared minus 4x. Change the signs, add them together, and we get 2x, and then we bring down the minus 8. X goes into 2x just 2 times. Multiply 2 by the x minus 4, we get 2x minus 8. We're going to change our signs, and we get 0. Okay? We can check these by taking x plus 2 and x minus 4, FOILing them out, and you'll see that we have the original number that we were dividing, x squared minus 2x minus 8. All right, let's take a look at this example, because this example is going to be a little different. Okay, how many times does p go into p squared? Just p. Then we have to multiply that through. We get p squared plus 6p. Change our signs, add them together. We get minus 4p plus 20. Again, how many times does p go into a minus 4p? It goes in minus 4 times. So remember, you're going to multiply that minus 4 by the p plus 6. So we'll get minus 4p minus 24. We're going to add these together. Notice that we get 44. This time we don't have a 0 left over. We actually have a remainder. So what does this look like? Notice how we put the remainder over the entire divisor, okay? And you can check this out, okay, by if you take p plus 6 and p minus 4, FOIL them out. Notice how the p plus 6 would cancel, and so you would wind up with the FOIL of a minus 24 plus a 44. And when you do the combining of your like terms, notice how you get p squared plus 2p plus 20. Okay, so again, take a look at how our remainder goes over the divisor. Okay, and these two things equal the same thing. The p squared plus 2p plus 20 divided by p plus 6 is equal to p minus 4 plus 44 over p plus 6. Okay, see how those actually are the same thing. Okay. And again, we can just work these out and see. Notice that we have two formats here. We have f of x over your whole function over the divisor, which is equal to the quotient plus the remainder over the divisor. Okay, and thus your f of x is equal to the divisor times the quotient plus the remainder. And that's what we've worked our way through in doing this, okay? So if f of x and d of x are polynomials such that d of x does not equal 0, and the degree of d of x is less than or equal to the degree of f of x, there exists a unique polynomials q, the quotient and remainder such that we can multiply the divisor by the quotient, add the remainder, and you will find your function again, where r equals 0, or the degree of r is less than the degree of d of x. Okay, These are just proper and improper, these two words. What do they mean? So since the degree f of x is more than or equal to d of x, the rational expression f of x divided by d of x is what we call improper. So that's why we do the long division, is to get it into the proper format, okay? So if your remainder is less than your divisor, then the rational expression r of x over d of x is proper. Thank you for your participation. The end.